It has hung in our sky for all of human history, a silent, silvery companion, a beacon for poets, a destination for dreamers. We have charted its phases, mapped its craters, and in one of our species' proudest moments, we have walked upon its surface. The moon is the most familiar object in our night sky, and yet it is a world that is profoundly, fundamentally, and beautifully alien. To stand on the surface of the moon is to stand in two worlds at once, the world of a rocky, familiar planet, and the world of the pure, unfiltered, silent cosmos. Tonight we take you on that journey. We will stand in the dust of the lunar highlands, and we will look up. We will explore the strange and breathtaking vista of a sky without air, a place of perfect blackness and razor-sharp shadows. We will witness the Earth rise, a brilliant blue marble in the void, and we will see the universe as it was meant to be seen. Prepare to experience the ultimate off-world perspective. Prepare to see what space looks like from the surface of the moon. The first thing you would notice, the first profound and deeply unsettling difference upon standing on the lunar surface, is the sky. Imagine a perfect, sunny afternoon. The sun is blazing above you, a brilliant, white, and ferocious disk of light. The ground beneath your feet, a landscape of gray dust and rock, is illuminated in a harsh, brilliant glare. And yet, when you look up, the sky is not blue, it is not hazy, it is not even dark. It is a perfect, absolute, and profound blackness. This is the jarring and beautiful reality of a world without an atmosphere. On Earth, our sky has color because of a phenomenon called Rayleigh scattering. Our atmosphere is a thick, dense ocean of gas molecules, mostly nitrogen and oxygen. As sunlight, which is made of all the colors of the rainbow, streams through this atmosphere, it collides with these tiny gas molecules. The shorter, bluer wavelengths of light are scattered more effectively by these molecules than the longer, redder wavelengths. This scattered blue light is then sent careening in all directions, and it is this ambient, scattered light that fills our sky, making it appear as a brilliant blue dome. The sky itself is glowing, illuminated by the sun. But the moon has no such ocean of air. It is, for all practical purposes, in a perfect vacuum. There are no gas molecules to scatter the sunlight. The light from the sun travels in a perfectly straight line from its source to your eyes or to the ground. It is not scattered. It does not diffuse, and so the sky itself has no color. It has no light of its own. It is a canvas of pure, empty, and infinite black. The visual experience would be utterly alien. Imagine being on a vast, dusty plain at noon, under the brightest sun you can imagine. And yet, if you were to simply hold your hand up to block the direct glare of the sun, you would be able to see the stars. You could see Jupiter, Saturn, and the brilliant, star-filled band of the Milky Way, all in the middle of the day. The concepts of day and night, as we know them, as a division between a bright sky and a dark sky, have completely lost their meaning. On the moon, it is always day and it is always night at the exact same time. This perfect blackness has a profound effect on the entire visual environment. The light is not soft or gentle. It is a hard, sharp, and brutally direct light. It is like being on a theater stage with a single, powerful, undiffused spotlight, and all the other house lights turned off. There is no ambient light. There is no gentle fill light. There is only the direct, harsh glare of the sun and the reflected light from the ground. This is the first and most fundamental lesson the moon teaches us about space. The blackness we see between the stars is not just a feature of the night. It is the default state of the universe. It is the true color of the cosmos, a color that is only hidden from us on Earth by the beautiful, life-giving, and light-scattering blanket of our own atmosphere. To stand on the moon is to see the universe raw, unfiltered, and in its true, stark, and magnificent colors, the brilliant white of the sun, the soft gray of the dust, and the perfect, unending black of the void. The second consequence of a world without an atmosphere, a direct and dramatic result of the blackness of the sky, is the nature of its shadows. On Earth, shadows are soft, gentle things. If you stand in the shadow of a tall building on a sunny day, you can still see perfectly. The world inside the shadow is filled with diffuse, ambient light, the blue light that is scattered by the atmosphere and the reflected light from the surrounding environment. Shadows on Earth are places of shade, not places of true darkness. On the Moon, a shadow is a place of profound, impenetrable, and dangerous blackness. A shadow on the Moon is not shade. It is an absence. It is a hole in the visual world, because there is no air to scatter the sunlight. There is no ambient light to fill the shadows. The only light that exists is the direct light from the sun, the faint light reflected from the distant Earth, and the light that bounces off the lunar surface itself. This is not enough to illuminate the shadows in any meaningful way. When the Apollo astronauts walked on the Moon, this was one of the greatest and most unexpected operational challenges they faced. The landscape was a world of extreme binary contrast. The sunlit areas were blindingly bright, and the shadowed areas were pools of almost perfect black. An astronaut looking into a shadowed crater would see not a gentle, sloping depression, but a black, featureless void. A rock that was half in sunlight and half in shadow would appear as if it had been neatly cut in half, one side brilliantly lit, the other side completely gone, swallowed by the darkness. This made navigation incredibly difficult and dangerous. The astronauts had to learn to walk and to drive their lunar rover in an environment where a deep, dangerous crater just a few feet away might be completely invisible to them if it was in shadow. They had to rely on the shape of the crater's sunlit rim to infer its depth. They often described the feeling as being in a strange, surreal, and sometimes disorienting dreamscape. This tyranny of light and shadow is most extreme near the lunar poles, in the deep, permanently shadowed craters at the Moon's north and south poles. There are regions that have not seen direct sunlight in over 2 billion years. The only light they ever receive is the faint, reflected starlight and the gentle glow of the distant Milky Way. The temperatures inside these craters are among the coldest in the entire solar system, dropping to as low as -250 degrees Celsius, colder even than the surface of Pluto. It is within these ultra-cold, permanently dark traps that scientists have discovered the frozen water ice that could be a vital resource for future lunar colonists. The experience of a lunar shadow is a direct, visceral lesson in the physics of light. It teaches us that our world on Earth is a soft focus, forgiving place, a world where the air itself acts as a natural diffuser, softening the harsh glare of our star and gently illuminating the dark corners. The Moon offers no such comfort. It is a world of pure geometric light, a place where the boundary between light and darkness is as sharp and as absolute as the edge of a knife. From the silent, gray, and starkly beautiful landscape of the Moon, there is one sight that transcends all others, one view that, more than any other, has the power to fundamentally alter our perspective on ourselves and our place in the cosmos. It is the sight of our own home. It is the view of the Earth, hanging like a brilliant, living jewel in the eternal black night of the lunar sky. The Apollo astronauts were the first human beings to ever witness this sight, and it affected them profoundly. They described it as the most beautiful thing they had ever seen. From the Moon, the Earth is a small but stunningly bright disk of color and light. It is about 4 times the diameter of the full moon in our own sky, and depending on the reflective cloud cover, it can be up to 50 times brighter. It is a world of breathtaking and dynamic beauty. You would see the deep, brilliant blue of the oceans, the swirling, ever-changing patterns of the white clouds, and the familiar continental shapes of the continents. their colors shifting from the green of the forests to the tan of the deserts. And unlike the moon, which appears as a static gray ball in our sky, the Earth from the moon is visibly, vibrantly alive. You would be able to see the full planet rotating, a slow, majestic 24-hour pirouette, revealing new continents and new weather patterns as it turns. But the most strange and counterintuitive aspect of this view is that for an observer standing on the moon, the Earth does not rise or set. This is due to the phenomenon of tidal locking. Just as the moon always shows the same face to the Earth always shows the same face to the moon. This means that if you were to build a house on the near side of the moon, the side that always faces us, the Earth would hang in the exact same spot in your sky forever. It would never move. It would simply hang there, silently rotating and going through its phases. The phases of the Earth would be the reverse of the phases of the moon we see. When we on Earth see a new moon, an observer on the moon would see a brilliant, dazzling full Earth. And when we see a full moon, the lunar observer would see a new Earth, a dark disk with only its atmospheric rim faintly illuminated. The only time the Earth would move significantly in the sky would be due to a slight wobble in the moon's orbit, a phenomenon called libration, which would cause the Earth to trace a small, slow oval in the sky over the course of a month. The famous and iconic Earthrise photograph, taken by the crew of Apollo 8, is therefore a little misleading. It was not taken from the surface. It was taken from a spacecraft that was in orbit around the moon. It was the motion of their own spacecraft, as it came around the limb of the moon, that created the beautiful illusion of the Earth rising. For a stationary observer on the surface, this event would never happen. To stand on the lunar surface and look up at the Earth would be a life-altering experience. It is to see our entire world, all of its history, all of its conflicts, all of its beauty, all 7 billion of us, contained in a single, small, and fragile-looking sphere. It is a view that provides the ultimate perspective. It shows us that our world is not the vast, limitless plane it appears to be, but a small, finite, and precious island of life, adrift in a vast and silent cosmic ocean. With the brilliant Earth hanging motionless in the sky, and the harsh, unfiltered sun journeying slowly across the heavens, what of the other stars? The moon, with its lack of a light-scattering atmosphere, is perhaps the greatest place in the inner solar system from which to practice the ancient art of astronomy. The view of the cosmos from the lunar surface would be one of incredible clarity, stability, and beauty. The first and most striking difference is that the stars would not twinkle. The twinkling of stars, the beautiful, shimmering effect that we see from Earth, is not a property of the stars themselves. It is an artifact of our own turbulent atmosphere. As the light from a distant star travels through the layers of air in our sky, it is bent and distorted by the moving pockets of air of different temperatures and densities. This constant, rapid distortion is what causes the star's image to appear to shimmer and change in brightness. But on the moon, there is no air to disturb the starlight. The light travels in a perfectly straight line from the star to your eye. The stars would be sharp, steady, and unwavering points of light. They would be perfect, hard, diamond-like points, shining with a pure, constant, and piercing light. The second difference would be the sheer number of stars visible. On Earth, even in the darkest locations, the faint, residual glow of the atmosphere itself, a phenomenon called air glow, washes out the faintest stars from our view. On the moon, with its perfect black sky, the limiting factor would only be the sensitivity of your own eyes. You would be able to see thousands more stars with the naked eye than are visible from Earth. The band of the Milky Way would be a breathtaking, intricate river of light, its great dust lanes and glowing nebulae resolved in stunning detail. Faint, distant objects, like the Andromeda galaxy, would be a clear and obvious smudge of light in the sky. This incredible clarity is why the moon is considered the ultimate location for a future generation of astronomical observatories. A visible light telescope placed on the moon would have a view that is as clear and as stable as the Hubble or James Webb Space Telescopes, but with the added advantage of being on a solid, stable, and large platform. But the real scientific prize of lunar astronomy lies on the far side of the moon. The far side is the hemisphere that is permanently turned away from the Earth. It is the only place in the entire inner solar system that is completely shielded from the constant and incredibly loud radio noise generated by our own civilization. Earth is a clamorous planet, constantly broadcasting radio and television signals, radar, and other communications out into space. This radio interference is a major challenge for radio astronomers on Earth, who are trying to listen for the faint, whisper-like radio signals from the distant universe. The far side of the moon is the quietest place we know of. A radio telescope built on the far side would be in a perfect, radio-silent environment. It would be able to listen to the cosmos with a clarity and sensitivity that is simply impossible to achieve on Earth. It could be used to study the dark ages of the universe, the period before the first stars ignited, by looking for the faint, red-shifted radio signals from the primordial hydrogen gas. It could be used to search for the faint, telltale radio signals of extraterrestrial intelligence, free from the cacophony of our own planet's broadcasts. The moon, in this sense, is not just a destination. It is a platform, a window that could open up our view of the universe in ways we can only just begin to imagine. Our experience of time on Earth is governed by the rapid 24-hour spin of our planet. The constant and reliable cycle of a 12-hour day and a 12-hour night is the fundamental rhythm of our biology, our societies, and our world. To stand on the moon is to abandon this rhythm and to enter a new and profoundly alien temporal landscape. A day on the moon, the time it takes for the sun to journey from one horizon to the next, is not measured in hours. It is measured in weeks. As we have learned, the moon is tidally locked to the Earth. This means its rotation period is the same as its orbital period. The time it takes for the moon to spin once on its axis is the same time it takes for it to complete one full orbit around the Earth. This time is about 29.5 Earth days. This is the length of a single lunar day-night cycle. Imagine standing on the lunar equator at sunrise. The sun would appear as a brilliant, blindingly white disk, rising with an almost imperceptible slowness from behind the curved, dusty horizon. It would then begin its long, slow journey across the black sky. It would take a full 2 weeks for the sun to travel from the eastern horizon to its high noon position directly overhead and then down to the western horizon. This would be a 2-week-long day of continuous, unrelenting, and unfiltered sunlight. During this long lunar day, the temperature of the surface would climb to brutal extremes, with no atmosphere to distribute the heat. The sun-baked lunar dust can reach a temperature of over 120 degrees Celsius, or about 250 degrees Fahrenheit. This is hotter than the boiling point of water. Any lunar habitat or spacesuit would need a robust cooling system to survive this constant 2-week-long thermal assault. Then, as the sun finally sets, an equally long and equally extreme night begins. The sunset would be a strange and beautiful event, with no atmosphere to scatter the light and create the familiar, lingering colors of a terrestrial twilight. The moment the sun's disk disappears below the horizon, the world would be plunged into an instantaneous and absolute darkness, lit only by the stars and the brilliant, motionless Earth in the sky. And then the deep freeze begins. For the next 2 weeks, the surface will be in total darkness, with no atmospheric blanket to trap its heat. The lunar surface radiates its warmth away into space with brutal efficiency. The temperature of the dust will plummet to as low as -173 degrees Celsius, or -280 degrees Fahrenheit. This is a cold that is far beyond anything experienced on Earth, a cold that would make any exposed equipment brittle and fragile. This extreme month-long cycle of fire and ice is one of the greatest challenges for any long-term human presence on the Moon. Any lunar base would need to be able to withstand a temperature swing of nearly 300 degrees Celsius with every day-night cycle. It would need a power system that could generate and store enough energy during the 2-week day to keep the habitat warm and functional through the 2-week night. To live on the Moon is to live in a world of profound temporal strangeness. It is to abandon the familiar rapid pulse of our own world and to adapt to a new, slow, majestic, and unforgiving rhythm. A rhythm dictated by the long, silent dance of gravity between the Earth and its lonely, loyal companion. From the surface of the Moon, the Sun is a paradoxical object. It is the source of all light, the reason the landscape is so brilliantly illuminated, and yet it is also a source of immense danger, a weapon in the sky. On Earth, we are protected from the Sun's worst excesses by a series of powerful planetary scale shields. On the Moon, there are no such shields. To stand on the Moon is to be exposed to the raw, unfiltered, and dangerous power of a star. The first and most obvious danger is the sheer intensity of the sunlight. With no atmosphere to scatter or absorb the light, the sun's glare is a constant and blinding presence. The Apollo astronauts' helmets were equipped with a special gold-coated visor, which acted as a powerful pair of sunglasses, reflecting away most of the visible light and harmful radiation to protect their eyes. Without such protection, an astronaut would be blinded in seconds. But the real danger is not in the light we can see, but in the light we cannot. The sun is a powerful source of high-energy ultraviolet radiation. On Earth, the ozone layer in our stratosphere absorbs 98% of this harmful UV light. On the Moon, there is no ozone layer. The surface is bathed in the full, unattenuated blast of solar UV. Any exposed skin would suffer a catastrophic sunburn in a matter of seconds. And this radiation is powerful enough to break down and degrade many materials, a major challenge for the design of long-lasting lunar habitats and equipment. But the sun does not just emit light. It also emits a constant stream of charged particles, the solar wind. On Earth, our powerful magnetic field, the magnetosphere, deflects this wind, protecting our atmosphere from being stripped away. The Moon has no global magnetic field. Its surface is directly exposed to the full, unrelenting force of the solar wind. For billions of years, the lunar soil has been bombarded by these high-energy protons and electrons. This bombardment has subtly changed the chemistry of the lunar dust, and it has implanted light elements, like hydrogen, from the sun into the soil, a potential resource for future explorers. The greatest and most unpredictable danger of all, however, is a solar flare. A solar flare is a sudden, violent explosion on the sun's surface, which can unleash a massive burst of high-energy X-rays and charged particles into the solar system. On Earth, we are almost completely protected from these events by our magnetic field and our thick atmosphere. On the Moon, there is no protection. If a powerful solar flare were to erupt while astronauts were on a spacewalk on the lunar surface, it would be a life-threatening emergency. The astronauts would be hit by a wave of intense radiation, a dose that could be lethal. They would have only a few minutes to get back to the shelter of their lander or habitat, which would need to have its own dedicated radiation shielding, perhaps by being buried under several meters of lunar soil. Predicting these solar weather events and having a plan to shelter from them is one of the most critical aspects of planning for a long-term human presence on the Moon. The sun from the Moon is a constant reminder that a star is not just a gentle, life-giving source of warmth. It is a powerful and sometimes violent nuclear reactor. To live on a world without an atmosphere and a magnetic field is to live with the constant ambient threat of its unfiltered power. We have explored the sights of the moon, the black sky, the harsh shadows, the brilliant earth, and the unblinking stars. But what of the other senses? What would it feel like? What would it sound like to stand on the lunar surface? The answer to the second question is the simplest, and perhaps the most profound difference between the Earth and the Moon. The Moon is a place of perfect, absolute, and eternal silence. Sound is a mechanical wave. It is a vibration that needs a medium to travel through. On Earth, that medium is the air. A vibrating object, like a guitar string or our own vocal cords, pushes and pulls on the air molecules around it, creating a pressure wave that travels to our eardrums, which we then perceive as sound. The denser the medium, the better and faster sound travels. But the Moon has no air. It exists in a near-perfect vacuum. This means that on the Moon, there is no medium for sound to travel through. It is a world without sound. Imagine standing on the lunar surface, next to your fellow astronaut. You could be shouting at the top of your lungs, and they would not hear a single thing. The sound waves from your voice would have no air to propagate through. All communication must be done through the radios in your helmets, turning every conversation into a long-distance call. If you were to watch the lunar lander take off from the surface, as the Apollo astronauts did, it would be the most surreal and unsettling spectacle. You would see the brilliant, fiery plume of the rocket engine. You would see the ground shake and the dust fly. You would feel the vibrations through the soles of your boots, but you would hear nothing. The most powerful and violent event you have ever witnessed would take place in complete and utter silence. It would be like watching a movie with the sound turned off. This profound silence would have a deep psychological effect. We are a species that is accustomed to a constant, ambient soundscape. The rustle of leaves, the call of birds, the distant hum of traffic, the sound of our own breathing. On the Moon, all of this is gone. The only sounds an astronaut would hear would be the sounds of their own life support system, the hum of the fans circulating their air, the crackle of the radio in their helmet, the sound of their own heartbeat and their own breathing. It is an experience of profound isolation, a reminder that you are a solitary being encased in a fragile bubble of technology, in a universe that is completely indifferent to your presence. But the silence is also a source of incredible peace. The Apollo astronauts often spoke of the deep, almost spiritual sense of tranquility they felt while on the Moon. It is a silence that is deeper and more profound than any silence that can be experienced on Earth. It is the true sound of the cosmos itself, the sound of a universe without air, a universe where the great, majestic, and violent events of creation and destruction all unfold in a silent, cosmic ballet. To stand on the Moon is not just to see the universe in a new way, it is to hear it, or rather not hear it, in a way that is fundamentally and forever transformative. We have spent our journey looking up at the magnificent and alien vistas of the lunar sky. Now we turn our gaze downward to the ground beneath our feet, for the surface of the Moon is a world in itself, a landscape of profound strangeness, shaped by 4.5 billion years of cosmic history. The surface is covered by a fine, dark, and surprisingly complex material known as the lunar regolith. It is not sand, it is not soil. It is a substance unique to the airless worlds of the solar system. The regolith is a thick, powdery blanket of dust, shattered rock, and tiny glass beads that covers the entire Moon to a depth of several meters. It is the product of an eternal slow-motion cataclysm. For billions of years, the Moon has been relentlessly bombarded by a constant rain of micrometeoroids, with no atmosphere to protect it. Even the tiniest, sand grain-sized particle from space slams into the surface at speeds of tens of thousands of kilometers per hour. Each of these tiny impacts is a microscopic explosion. It excavates a tiny crater and shatters the rock at the impact site, breaking it down into smaller and smaller fragments. The intense heat of the impact also melts a small amount of the rock, which is then flung out and cools rapidly into tiny glassy spheres. The lunar regolith is the accumulated debris of these countless trillions of impacts. It is a planetary surface that has been gardened, churned, and pulverized over geological time. To walk on this surface, as the Apollo astronauts did, is a unique experience. The dust is finer than sand, with the consistency of powdered snow or talcum powder. It is also incredibly abrasive. The individual dust grains are not worn down and rounded by wind and water like sand on an earthly beach. They are sharp, jagged, and glassy shards of rock. This abrasive dust was a major nuisance for the astronauts. It clung to their spacesuits, clogged their equipment, and wore down the seals on their gloves. The lunar dust also has a strange electrical property. Because there is no air and no moisture, it is a perfect electrical insulator. When it is struck by the high-energy particles of the solar wind and the ultraviolet radiation from the sun, it can build up a significant static charge. This caused the dust to actively levitate and cling to the astronauts' suits, as if it were alive. In the twilight hours of a lunar sunrise or sunset, this electrostatic levitation can even cause a faint, hazy glow to appear just above the horizon as charged dust particles are lifted a few meters off the surface. It is a kind of dust atmosphere. Perhaps the most beautiful visual effect of the lunar dust is a phenomenon called the Heiligenschein, or holy glow. An astronaut standing on the surface would notice a brilliant, ethereal halo of light around the shadow of their own helmet. This is caused by the way the rough, porous surface of the regolith reflects light. The dust is very good at reflecting light directly back towards its source. When you look at the shadow of your own head, you are looking at the one spot on the landscape where all the shadows cast by the individual dust grains are hidden behind the grains themselves. You are seeing the full, unshadowed reflectivity of the dust, which creates this strange and beautiful halo. It is a personal, moving spotlight that follows you wherever you go. The very ground beneath your feet is a dynamic and alien substance, a powdered ocean of shattered history that tells the story of the moon's long and violent past. The view from the surface of the moon is not just a view of a place, it is a view of time. The lunar landscape is a perfectly preserved museum of our solar system's history, a story told in scars, craters, and ancient solidified oceans of lava. To learn to see the moon is to learn to read the pages of a 4.5 billion-year-old history book. From any point on the lunar surface, the landscape is dominated by two distinct types of terrain, a duality that tells the story of the moon's violent youth. The first are the lunar highlands, or terrae. These are the bright, whitish, and heavily cratered regions that make up about 80% of the moon's surface and almost all of its far side. These are the original, primordial crust of the moon, formed from the cooling of a global magma ocean shortly after the moon's birth. The highlands are ancient, rugged, and saturated with craters, a testament to a period of intense, violent bombardment in the early solar system. The second type of terrain are the lunar maria, or seas. These are the dark, smooth, and relatively uncratered plains that are prominent on the moon's near side, forming the features of the man in the moon. The name is a relic of early astronomers who mistook them for actual oceans. We now know that they are vast, solidified floods of basaltic lava. Between about 4 and 3 billion years ago, the moon was still geologically active. The decay of radioactive elements in its interior produced a tremendous amount of heat, melting parts of its mantle. This molten rock then erupted onto the surface, often through the fissures created by the largest, most ancient impact basins. These colossal lava flows poured out over hundreds of thousands of years, flooding the low-lying craters and basins of the highlands and creating vast, smooth plains. The difference in cratering between the highlands and the Maria is the key to a crucial chapter in our solar system's history. The highlands are saturated with craters, while the Maria are relatively smooth. This tells us that there was a period of incredibly intense bombardment very early in the solar system's life, which created the highland craters. Then, after this bombardment had largely subsided, the lava flows of the Maria erupted, paving over the older craters and creating a fresh, new surface. This early, intense period of cratering is known as the Late Heavy Bombardment. It was a time about 4 billion years ago when the orbits of the giant planets were shifting, sending a storm of asteroids and comets careening into the inner solar system. The moon's battered face is the most pristine surviving record of this violent epoch. The Earth would have been hit by even more and even larger objects during this time. But the evidence on our own world has been almost completely erased by the relentless action of plate tectonics, wind, and water erosion. To stand on the moon is to be a geologist on a dead world. You can see the sharp, relatively young craters, with their brilliant rayed systems of ejected material. You can see the older, softer, more eroded craters from billions of years past. You can stand on the shore of a dark, frozen sea of lava and look up at the bright, ancient, cratered highlands that form its coast. The entire history of the solar system, its fiery birth, its violent youth, and its long, quiet, and unchanging adulthood, is written in the gray and silent rock of the lunar landscape. The view from the moon is not just a view of cosmic and geological history. For our species, it is also a view of our own history. Scattered across the sun-scorched plains and highlands of the near side are 6 very special locations. These are the landing sites of the Apollo missions, the places where, for a brief and glorious moment in time, human beings left their home world and walked upon the surface of another. To visit one of these sites today would be an experience of profound and eerie stillness. The sites are perfectly preserved, untouched by time, silent monuments to one of the greatest achievements in human history. Let us imagine standing at the Tranquility Base, the landing site of Apollo 11. The descent stage of the lunar module, the Eagle, still stands on its 4 spindly legs, its gold foil insulation gleaming in the harsh sunlight. It is a silent, abandoned relic, a piece of human technology left behind as a permanent marker of our first visit. And leading away from the lander are the most famous and most poignant artifacts of all, the footprints. The boot prints of Neil Armstrong and Buzz Aldrin are still there, perfectly preserved in the fine, powdery lunar dust. With no wind to blow them away, no rain to wash them out, and no geological activity to disturb them, these footprints will remain, sharp and clear, for millions of years. They will likely outlast every structure we have ever built on Earth. They are a silent, enduring testament to the fact that we were there. They are our species' first, and so far only, mark on another world. The site would be littered with the other artifacts of that first, brief excursion. The American flag, now likely bleached white by decades of unfiltered ultraviolet radiation, still stands, though it may have been knocked over by the blast of the ascent engine. The scientific instruments of the early Apollo Scientific Experiments Package, or EASEP, still sit on the surface, their mission long since completed. Every discarded piece of equipment, every footprint, every rover track at the later Apollo sites tells a story. The landing sites of the later missions, like Apollo 15 and 17, are even more expansive. You could see the abandoned lunar roving vehicles, the electric cars that allowed the astronauts to explore for miles across the lunar landscape. Their tracks, a pair of parallel lines snaking across the hills and valleys, are still there, a map of the first human road trip on another world. To visit these sites would be to visit a museum, a historical park, an archaeological site of immense significance. They are protected, not by any law we could pass, but by the perfect, sterile, and unchanging nature of the lunar environment itself. They are a message to the future, a sign of what our species is capable of when it unites in a common, audacious goal. The view of space from these sites is forever changed. It is no longer just a view of a natural, pristine landscape. It is a view that is now part of our own story. When you look up at the brilliant, silent Earth hanging in the black sky, you do so knowing that you are standing in the footprints of those who first made that journey, the pioneers who turned a point of light in our sky into a world beneath our feet. The footprints of the Apollo astronauts are a monument to a past age of exploration. For over 50 years, no human has ventured beyond the cradle of low Earth orbit. The Moon, once the destination of a generation, has been a silent and empty world. But that is about to change. The view from the Moon is not just a view of the past. It is also a view of our future. We are going back. A new international effort, led by NASA's Artemis program, is now underway to return human beings to the lunar surface. But this time, the goal is not just to plant a flag and take a few samples. The goal is to stay. The vision is to build a permanent, sustainable human presence on the Moon, a scientific outpost, a proving ground for new technologies, and a stepping stone for the next, even greater, giant leap, a human mission to Mars. The first Artemis missions will be a return to the lunar equator, much like the Apollo landings. But the ultimate destination for this new era of lunar exploration is the lunar South Pole. This is a region of immense scientific interest and strategic importance. As we have learned, the South Pole is home to permanently shadowed craters, regions that have not seen sunlight in billions of years. Within these ultra-cold traps, orbiting spacecraft have detected vast quantities of water ice. This water is the single most valuable resource on the Moon. It can be harvested and melted to provide drinking water for astronauts. It can be broken down into its constituent elements, hydrogen and oxygen, to provide breathable air, and that same hydrogen and oxygen are the two primary components of rocket fuel. The Moon, in effect, could become a cosmic refueling station. We could launch rockets from Earth, refuel them with propellant mined and created on the Moon, and then send them on to Mars and the outer solar system. The lunar South Pole could be the key that unlocks the rest of the solar system. The view from the South Pole would be unlike anything the Apollo astronauts ever saw. The sun would not rise and set in the same way. Instead, it would circle the horizon, never rising very high in the sky. This creates a bizarre and challenging environment of long, dramatic, and constantly moving shadows. But it also means that the rims of some of the polar craters are in near-permanent sunlight, making them ideal locations for solar power arrays. A future lunar base, the Artemis Base Camp, would be a settlement of incredible ingenuity, pressurized habitats, perhaps connected by tunnels or built underground for radiation shielding, would house a rotating crew of astronauts. Robotic rovers would be sent into the dark, frozen craters to mine for water ice. A power grid of solar panels and fuel cells would provide the energy needed to run this off-world settlement. It would be a true, permanent human foothold on another world. From this base, we would have a new and more permanent view of space. We would have astronomers operating telescopes on the far side. We would have geologists exploring the ancient history of the lunar highlands. And we would have astronauts looking up at the familiar, brilliant Earth in the sky, not as visitors, but as residents of a second world. The next great era of human exploration is dawning, and its destination is the same beautiful and silent world that has inspired us for all of our history. Our journey is complete. We have stood on the dusty, silent plains of the Moon and have witnessed the magnificent and alien vistas of a world without a sky. We have seen the sun, not as a gentle source of warmth, but as a brilliant, unfiltered star, shining in a heaven of perfect blackness. We have felt the profound silence of a world without air and have been humbled by the tyranny of its light and shadow. From our lunar vantage point, we have looked up at the unblinking stars, a view of perfect clarity, and we have looked back at our own world, a brilliant, beautiful, and living marble of blue and white, hanging motionless in the eternal night. We have read the violent, 4 billion-year-old history of our solar system in the moon's cratered face, and we have seen the silent, enduring footprints of our own brief, audacious visit. What this journey teaches us, more than anything, is the power of perspective. To stand on the moon is to experience the ultimate overview effect. It is to see our own world, not as the center of the universe, not as a vast and limitless home, but as a small, fragile, and breathtakingly beautiful exception. It is a view that strips away our terrestrial biases. The blackness of the lunar sky reminds us that our blue sky is a precious and life-giving gift of our atmosphere. The silence of the lunar landscape reminds us that the sounds of our world, the wind, the water, the sounds of life, are a rare and beautiful symphony. And the sight of our own, vibrant and dynamic Earth, set against the stark, gray, and dead backdrop of the moon, is the most powerful reminder of all of just how special, how lucky, and how worthy of our protection our own world truly is. The view from the moon is therefore a mirror. We journey across 250,000 miles of empty space, not just to see another world, but to truly see our own for the first time. It is a journey into the stark reality of the cosmos that ultimately reveals the profound and beautiful miracle of home.